Hi, welcome back for another 7 Caillou challenge. This one's called 789. There's not much to say here. Write a function that removes every lone 9 that is between 7s. So check out the two examples that they give. In this input, you'll notice the 9 in the second spot is removed because it has a 7 preceding it and a 7 after it. Similarly, in example 2, you've got the same sort of thing going on where this 5-digit number is reduced to a 3-digit number with the 9s removed because each 9 has a 7 preceding it and after it. So I think they could have done a better job showing more examples here because when I first attempted this, I did more work than I had to do. But I think I can make it clear if you take a look at this first test case here. And notice that you have two 9s occurring in it, right? We have this stretch where there's a 7, 8, 9, 7. But you'll notice that's preserved in the expected value. Remember, in these test cases, they give you the input, and then they tell you what the expected answer should be. And notice in the expected answer, they say that 9 should be there. They did get rid of this 9, but not the previous one. And so what they mean then is that the 9 has to be immediately preceded by a 7 and immediately followed by a 7. So you see the string 797. When they just said remove the lone 9, in my mind, just looking at this bit I have highlighted, that is a lone 9. It's a single 9. But you know, lone, I guess there's nothing else that accompanies it. So maybe I just read that wrong. Either way, I wanted to possibly save you some hassle, so you're aware of that. Otherwise, you should be clear to proceed. You know to pause the video and make your own implementation and come on back when you're ready. Solve it. Let's do that. I'll go over a couple solutions. I'll use one with regular expressions, which I think makes sense for solving this. And then since this is a relatively beginner-friendly course, or very much so, we'll make our own implementation. We won't rely on regular expressions. It's important that you can do the work that these library functions give you. They're nice, but if you're learning, it helps that you can actually implement these things on your own too. So it'll be a good exercise. But if you want to leave after the regular expressions, feel free. If you still are learning, I highly encourage you to stick around for both parts. So let's get into a regular expression solution. And if you'd like to pull up the docs page for that, go ahead. We've done more than a few videos with that, so I assume you can find the docs page for it now if you're interested in making patterns and whatnot. So to that end, before we even get started, I should bring in system text regular expressions, right? That's what we need for that regex class that we use. And so to do this, basically, let's specify our pattern first. That's what regular expressions do, right? They match patterns. And for my pattern, I want 7, 9, 7 is going to be my pattern, but I want to specify, well, actually this should work because it's just a single 9, is like I tried to explain in the beginning there when we looked at the test case. So I'll make 797 my pattern, and then you may think to do something like this: return regex replace, right? We know it has a replace method where you give it the input, you give it your pattern, and then you specify what you want to replace it with. So you would say like 797, when you remove that middle 9, should be replaced with just 77, something like this, right? So we'll go hit that. Okay, so it kind of worked, right? You see these first two examples passed just fine. But you'll notice there was a problem with example 3 here, which is alternating 797979. So what went wrong, right? Well, you can imagine we were searching for this pattern 797. We find it in the first 3 digits, right? First 3 characters, digits. And we replaced what I have highlighted with 77, right? So then it goes to 979. So effectively it skips over the 9, finds another 797, excuse me, and replaces that with 77. So you can imagine 77977. And you see our error message here is telling us that's exactly what we returned, but it's wrong. We know that the output should be 4 7s, right? So yeah, we kind of had that skipping, if you will, right? We processed the first 3, then we moved on and missed a 797 in the middle. So one way you could address that is you could do something like this. We could loop, it certainly won't loop very much, but you could go while regex is match, returns a Boolean, right? It just means it found your pattern. While that, we could say string equals regex replace string pattern. And you know, you're probably comfortable enough now. We don't even need to make a separate variable for the pattern, right? But if you like that, if it's more clear, go ahead and keep it. But you could do something like while regex is match, meaning while you find this pattern in the string, you're going to update the string. That's what this line's saying, right? You're assigning to string the value after replacing 797 with 77. And finally, after you've looped until you don't find any more of those, you can return string. So if we do something like this, main pattern, oh sure, so in that case, since we're duplicating, maybe you liked defining it in a local variable, so you're not repeating it twice, right? That then you run into the possibility of typing something wrong, right? So maybe the local variable is good. So we hit green, I'll attempt. Okay, green. So something like this works. You can see the difference being, this was the test case down below that failed before. So we're going to have, after that first pass through this while loop, right, we're going to replace it, and we saw our first wrong answer was 77977, and that's what string gets assigned to. But then it comes back up to the while loop, it looks for a match, and of course in the middle it finds that 797 again, so it replaces it with a 77. So you kind of, it gave us a second pass through the string, and it's updating the string each time. That's how it worked. So you could do something like that, and that's good enough. I think it's important that you can solve this problem not using regular expressions. So if you're interested in something like that, let's get to it. Maybe I'll keep this for the final submission. So I'll just comment it out now. That's how we do multi-line comments. You do that /**, and then you close them with asterisk and //. And that's nice when you have to comment many lines, because otherwise you're looking at doing double slashes on every line you want to comment, which works, but it's slow. So yeah, let's do it. Let's try another way. How else could we do this? Let's say there's no regular expression. Let's just have some fun doing this all on our own. So I'm going to use the string builder class. You could use the regular string class, but we know strings aren't so efficient when you're modifying them a lot. They're immutable collections of chars, and what looks like when you modify a string is actually creating a new string under the hood. So I'll use string builder, which is a class that's like having the ability to mutate a string. I'll just call it result generically. I'll say new string builder. We've used string builder a little bit in the past, but check your doc pages if you want, represents a mutable string of characters. And so you'll notice how with string we would use plus equals or plus when we want to concatenate letters together or strings together. With a string builder, you're going to use this append method instead. Same idea, you're just going to use append. So feel free to do any kind of reading you like on that. And then I'm basically going to step through all of the characters in the string. How do I do that? We're going to have a for loop for that, right? We'll go over that one by one. One thing I want to point out before I get further into this is that I'm actually going to initialize the string builder. Instead of having it be empty to start, I'm going to put the first character in, because no matter what, whether it's a 9 or something else, the first character is always in, because we know when a 9 gets replaced, it has to be preceded by a 7. And the first character, by definition, cannot be preceded by anything because it's the first character. So I will just say string substring 0, which means that's your index into the string. 0 means the first letter. And I'll say 1. You provide a count, how many letters you want to take from your index. So this is just sort of initializing me with, let's say we're dealing with this. It's going to start me out with a string builder. You can think of it like a string with just the number 7 in it so far. And then because I took that first character already, I don't have to start my index at 0. I can start at 1, right? I is less than string length and plus plus I. Typical for loop that we deal with, right? Good. So now we're at the point of examining each character in our for loop and making a decision. Now think about what are the two cases we're really interested in. Well, we're interested when a 9 comes up, basically. 9's sort of the magic number that we're looking for. If there's any other character number besides 9, we're letting it through. We're going to add it to our output. The only possible thing that can be removed from the input is the number 9, right? So we'll kind of have two cases. We'll say if string I is equal to the character 9, remember single quotes for characters. Now remember to have quotes. If you have this, that's an integer, right? You don't want that. We're looking for the character 9, so single quotes. So any digit we look at is either going to be a 9 or it's not going to be a 9. We're going to handle those two cases that we've handled everything. And then I suppose I can go ahead and put this in already. At the end, we're going to return our result, but note that you have to sort of convert it to a string, because result is a string builder, and our method signature, our contract, if you will, says you must return a string. So string builder provides this handy toString method that you can use when you're done building your string. Okay, so there's two special cases, or the two cases that we have to deal with, whether you have a 9 or a not. So let's, the case where it's not is incredibly simple. Let's say not equal to 9, right, in this part. That could be anything else. We're just simply going to pass it through, right, because we know that is part of the output. So we'll say result append string I. Let the character through, include it, start building it, attaching it to our output, put it on that first 7, add it to the end of that, right? That's what append means, add to the end. And then we're done there, right? So good. Now, the little slightly more involved case is when we are dealing with a 9. And so we have to determine, do we include the 9 or don't we? Because we saw it could go either way. So my strategy for doing this will be, I'm going to find the 9, and then I want to check both in front of and behind the 9 position, one spot back, one spot ahead, and see if both of those numbers are 7s. If either one of them is not a 7, then the 9 gets passed through. If they both happen to be 7s, sandwiching that 9, then we do not let that 9 be part of our output. That's sort of the strategy there. And I'm going to add a little flag to make sure it's safe for us to check ahead, because you can imagine that we're on the last character in the string, right? And if we try to look ahead one position from the last spot, that's accessing memory that's not part of the string, and that's bad. That causes problems. There's nothing there, right? Like there's nothing to match after the end. Just like we talked about at the front, why we included the first letter automatically. There was nothing before the first character that could have made it eligible to be removed. So with that in mind, I'm going to make this flag here. I'm going to say bool can check ahead to let me know that it's safe to look ahead one spot. And it will be as long as we're not on the last element. So in logic terms, that would be I, our index, is less than string length minus 1, right? It's strictly less than. I didn't say less than or equal. I said less than. String length minus 1 would be the last index position. And if I is less than the last one, it means there's at least one element ahead that we can look at. So we're sort of safe there. So given that flag, I could say if can check ahead, then I know it's safe to do that. And if I can't check ahead, the only time that happens is when I'm on the very last character, right? And we know even if the last character is a 9, it cannot be removed because there's nothing after. There's no 7 that could be after it. So in that case, we can just immediately make the else part there very simple. Result append string I. Okay, good. Okay, so now we're at the point where we can check ahead. And note, I didn't have to worry about checking behind because we started at index 1 here, right? So there's always a position 0. We can always go 1 at least. Or I should say we can always go 1 backwards. That's never going to cause trouble. So I didn't even worry about that here. So if we can look ahead, we're going to say if string, let's convert to code what I said before, our condition. If string I minus 1 being the previous letter, right? If that letter is not equal to the character 7, or string I plus 1 is not equal to 7, the character 7, then we can say, yeah, let that character through. Result append string I, right? But you can imagine, and I'm just going to do nothing. Notice I don't even put an else clause with this. So if it happens that the previous character is equal to the character 7 and the next one is equal to the character 7, then there's no else logic for us to even run. You could see from the rest of this else clause that we're in, there's nowhere else to reach, right? We don't get into this else. It just ends that iteration for that index, effectively skipping adding that index into our final result. So I'm just going to leave else blank. I don't have to do anything. We just let that letter get skipped. So I think that covers what we want to do. We're basically passing everything that that doesn't have a 9 that has a 7 before it, 7 after it. So we already handled returning result to string. So let's run a test here. Okay, can't use string builder. Sure, that's fair. Remember, you can go to your docs, you can look at the top and see that it resides in system text. So let's go ahead and bring system text in. Using system text. Let's try again. Okay, we hit green, attempt, and hit green. So we're golden there. One thing to note, it shouldn't be expensive to capture, to access the character in the input string here, but you'll see how the string I, we repeated that quite a bit, right? So something to think about, we repeated it here, we repeated it here. If that were a more costly operation, note that we could do something like, right at the top, you could say char ch equals string And then you pay that cost once, you have it stored locally here, and then you could just use CH in all those places. It's not bad here, but I just want you to be, thinking about stuff like that. Like if you were, instead of accessing an array, what if you were making a database call or something that could be more spendy, and you imagine hitting the database up this in all of those spots, to get the same letter, that'd be ridiculous. So we don't need it here, but little tip in case it helps you in other scenarios. So yeah, I'm going to submit the regular expression version, but that's cool. We did our own. We don't need the libraries. The libraries are a convenience for us. We know how to program. We can get it done without those. I'm not trying to tell you not to use them. You should use them, but when you're building your knowledge base, you want all the practice you can get. So I'll go back to this. Let's get the commented code out. I'll go ahead and submit. Wait, they're going to make us attempt again. Cool. We are clear. We'll collect our honor. And then, look through the other solutions. You got a nice one-liner there to start. You can look up, go to your regular expression reference page and look these up. See what else you can learn from other people. Otherwise, I'd love to see what you came up with. You know what to do if you have questions. Hit me up. Otherwise, I'll see you in another video. Thank you for watching.